Hello students, in this video we're going to learn about rational expressions. So at the end of this lesson, you should be able to simplify rational expressions using arithmetic and factoring. So let's get started. First we're going to talk about domain and functions. Now a domain refers to all of the values for which a function exists. This typically refers to the x values of a function. So as we go through examples A, B, C, and D, I want you to consider or figure out what you notice about the graph, its equation, and its domain. So let's look at A. So for part A, you'll notice that it's just a straight line. Now if we look at the x values, this line will continue to go diagonally in the same way that it's going, which means when x is 1, there is a value for the graph, which is right here. When x is 2, there's a value for that graph here. So at any value for x, this line still exists. So for that, we say all real numbers. For example, B, if we look at this graph, we need to figure out if there is a place where the x does not exist. So as we go through this example, or as we go through this graph, I want you to consider where x doesn't exist. So we're going to trace this line starting here, and as we go to the right, you'll notice that it starts to dip and then it goes away, and it's going to continue to go down, but all of a sudden it ends up here at the top, and it's going to go down to the right. Where we have an issue with it is right here at 3. So when x is 3, that graph doesn't exist. So we'll say all real numbers where x is not equal to 0, or where x is not equal to 3. And that's again because when we get to 3, that graph goes away. So if you look at the equation y equals 1 divided by x minus 3, if we substituted that 3 in that value, we get 3 minus 3, which is 0, and we can't have a 0 on the denominator. So let's look at C. For C, it looks like it stops down here at 0, but again, we're looking at the domain, or the x values. So as we go to the left, notice that there is an x value at every single point, even as it continues to the right, or to the left. And as we go to the right, it still exists. So for this part C, the domain is all real numbers. Now part D, I'm hoping you'll take a look, or you'll notice the difference between B and D. And you'll see that it has that same area where it doesn't exactly touch. So that's right here at -3, and that's right here at +3. These lines, these vertical lines that I'm drawing, are called asymptotes, which we'll talk about later. But in this instance, your answer, or your domain, is all real numbers where x does not equal 3, or x does not equal -3. So let's talk about simplifying rational expressions. To do that, I wrote down 3 easy steps to help you out. First, we're going to factor the numerator and denominators. Then we're going to cancel out like terms. And then we're going to determine the domain. So for example 1, let's take a look. If we're going to factor the numerator, we can figure out that the numerator has a 4 in common. So x minus 2, 4 times the quantity x minus 2. And on the denominator, using xbox, we can come up with x minus 2 times the quantity x minus 2. So now that we've done step 1, we factored out. Now we're going to do step 2, which is to cancel out like terms. So you'll notice here that we can cancel out this x minus 2 and this x minus 2. Keep in mind there's this 4 here, and it cannot be simplified with this 2 because they're not together. So your final answer should read 4 divided by x minus 2. So let's look at example 2. Again, it's the same exact idea. We're going to factor each one, so that's y minus 5 and y plus 1, all divided by y plus 4 times y plus 1. And you'll notice again that we can cancel things out, so that's what we'll do. We're going to cancel out y plus 1, and your final answer is y minus 5 divided by y plus 4, and that's your answer. So, example 3, it's the same exact thing. So x minus 7 times quantity x minus 7 divided by x plus 7 divided by x minus 7. So again, we're simplifying. We have y minus 7, y minus 7. Your final answer is x minus 7 divided by x plus 7. And that's your final answer. Now for each of these, you'll notice there's a denominator, and the denominator has a fraction. So in example 1, your domain would theoretically be all real numbers, where x does not equal 2. So again, start to see if you can figure out how we figure out where it doesn't exist. In example 2, we have all real numbers, where y does not equal -4. And lastly, all real numbers, where x does not equal -7. So in case you haven't noticed, the way we're figuring this out is we are taking the denominators and solving it for 0. So we have x minus 2 equals 0. When we solve that, we get x equals 2. And that's why we know x cannot be equal to 2, because that's when your x value, or that's when your denominator will be 0. Multiplying rational expressions. Again, same exact thing. We're going to we're going to factor all numerators and denominators, multiply across, and then cross cancel and cross cancel like terms. So let's take a look at example 1. So we have x minus 3 times quantity x plus 3 divided by x squared. We factor to the right of the multiplication sign, we have x times the quantity x minus 3, all divided by x plus 4 times x minus 3. We'll do our fraction bars. And now we're going to multiply across. So when we do that, we're going to be left with x minus 3. Notice I'm just rewriting the top lines. Times x minus 3, all divided by x squared, times x plus 4, x minus 3. So we multiplied across just like step 2 says, and we are going to cross cancel now. So we have an x minus 3 on the denominator, we have x minus 3 on the numerator. We have an x on the numerator, we have an x squared on the denominator, so we can cancel one of them out. And there's nothing else that we can cancel. So our final answer should read x minus 3 times the quantity x plus 3 divided by x times the quantity x plus 4. So that's how we solve or simplify rational expression with multiplication. Now we're going to save examples 2 and 3 for dividing rational expressions. For this, it's the same exact thing that we did in the last one. We are factoring all denominators, and because we're dividing, we're going to add one extra step, which is to copy dot flip. Then we're going to multiply across, and then cross cancel and cancel like terms. So notice the only thing we added here was copy dot flip. So I'll show you. Example 2, we're going to factor x plus 2, x minus 2. The denominator is x plus 5, x minus 2. The right side of division sign is x plus 3 times x plus 2, all divided by x plus 5 times quantity x plus 3. And I know that I'm factoring quickly, but I want to make sure we do this in the best interest of time. If you need help on factoring, you may want to go back and watch that video. So now we have our problem. We factored it out. Now we're going to copy dot flip. So you'll notice here, I'm going to rewrite this entire left side. So we're going to copy like I literally just did. We're going to change this divide sign to a multiply. Notice it's all in line with our copy dot flip. So we copied the first term, we changed it to a dot, and now we're going to flip the second term. So for this right side, it's now going to become x plus 5 times quantity x plus 3, all divided by x plus 3 times x plus 2. So now that we've copied dot flip, we're going to move on to 3. So when we do that, and we multiply, we are going to get x plus 2, x minus 2, x plus 5, x plus 3, and then the denominators, again, same exact thing, we're just multiplying across. Now when we cross cancel, we're looking for the same thing. So here we have x minus 2, x minus 2. We have x plus 5 down here, and x plus 5 up there, x plus 5 down here, x plus 2 up here, x plus 2 down here, x plus 3, x plus 3. So notice we didn't do a lot of actual multiplication, we just factored a lot of things and canceled things out. So because everything's canceled out, your answer is just 1. So we're going to move this over and try an example 3 real quick. Example 3, same exact thing. We're going to factor out, so that's x times the quantity x minus 25, which I'm going to skip, x squared, and do a little extra factoring, and then we're going to rewrite everything. So that's x times quantity x plus 5, x minus 5 because it's a difference of squares, and this is just 4x squared. We're doing multiplication now, and that's going to be, they have a common factor of 2, so that's 2 times x minus 1, x plus 1. So you'll notice for the x plus 1, x minus 1, I did an extra factoring job here because it's a difference of 2 squares. And then the denominator, it's going to become x minus 5, x minus 1. And then we have our division signs. So for the division portion, or to the right of division, they have a x in common, so x plus 5 divided by 7 times x plus 7, x plus 1. Put in our fraction bars. Okay, so for the left side, we're going to do the multiplication first. So again, we're multiplying across. So x times x plus 5, x minus 5. Again, just rewriting the entire first line. All divided by 4x squared, x minus 5, x minus 1. Now we're going to do, because it's a division sign, it's copy dot flip. So we copied the first expression, which we're just going to leave there. We're going to change the division into a dot, and then we're going to flip the entire second, or to the right of the division bar. So we flipped it. Now, so we can save a little bit of time on rewriting it, we are going to just do some cross canceling. So, if we pretended that we multiplied across, we're going to save ourselves some time from rewriting it again. Because we can cross cancel, I notice that there's an x plus 5 up here. There's an x plus 5 down here. We have x down here. We have an x up here. at this point in time, there's nothing else on this numerator that could be simplified with anything on... Oh, there is actually. There's x minus 5 here on the top, x minus 5 down here, x minus 1, x minus 1. That's it. I notice there's an x plus 1 and an x plus 1 here, but notice they're both on the numerator, so you can't cancel. So, now we're going to finally multiply across. We have 7 times x plus 1 times x plus 1, all divided by 4x squared. So, that's our answer for now. You'd want to multiply the x plus 1s, but we're going to go ahead and move on.